Types of work. The tool post and the tool slide can be angled as seen below. This allows the shaper to be used for different types of work. So there are three pictures. In the first picture, the tool post has been turned at an angle so that side of the material can be machined. In the next picture, the tool post is not angled so that the tool can be used to level a surface. And the third picture, the top slide is slowly fit into the material so that a rack can be machined for a rack and pinion gear system. There is a picture of these types of work and the basic movement of shaper machine. Cutting conditions in planning and shaping. The cutting conditions in planning and shaping are illustrated in the figure. Only the shaping operation is portrayed, but the cutting conditions are essentially the same and for planning. So there is the figure of cutting condition in orthogonal, left and the right, the oblique shaping. So there are some differences. You see here, there are so many indicators as B, D, S, D, feet, V, etc. Cutting velocity V. Cutting velocity V in the planning is linear and constant along the cutting path. In shaping, the picture is more complicated. The cutting tool is held in the tool post mounted in the ram, which reciprocates over the work with a forward stroke, cutting at velocity V, and a quick return stroke at higher velocity. The cutting velocity is therefore not constant along the cutting path. It increases from 0 to maximum in the beginning of the stroke and gradually decreases to 0 at the end of the stroke. The cutting speed v is assumed to be twice the average forwarded ram velocity. Feed f. Feed in planning and shaping is in millimeter per stroke and is at right angles to the cutting direction. Depth of cut d. Depth of cut is defined as usual as the distance between the work and machine surface. Effect of feed per stroke. Effect of feed per stroke on the flat surface generated in shaper. So there are two figures. First one is generation of a flat surface with a single point tool. There is the workpiece and there are the cutting speed. See here the depth of cut, the tool and the feed per stroke. In the next picture, they are almost similar. Then the combination of these three makes the first picture. Okay. There is a figure of clapper box in real life. Is see it here. Quick return mechanism. The shaping machine is used to machine flat metal surfaces, especially where a large amount of metal has to be removed. Other machines, such as milling machines, are much more expensive and are more suited to removing smaller amounts of metal very accurately. The reciprocating motion of the mechanism inside the shaping machine can be seen in the diagram. As the disc rotates, the top of the machine moves forward and backwards, pushing a cutting tool. The cutting tool removes the metal from the work, which is carefully bolted down. So you see here, there is animation and a figure. In the figure, you can see here all these things. There are the stroke, large arc distance, return stroke, small arc distance, cutting tool, tool head, and the stroke. All are indicated in this figure. And there is an animation of shaping machine. Quick return mechanism, hydraulic. This is the quick return mechanism of a hydraulic shaping machine. There are some indicators: cutting tool, work, shaper head, operating cylinder, cutting stroke, ram, trip dust control length, reversing lever, reversing valve, speed control pump, and reservoir. Planing machines. Planing is used for large workpieces too big for shapers. Planing machines have largely been replaced by planing mills. In planing, Large workpieces and their support tables are slowly moved against the tool head. So there is a figure of schematic of planners, double housing planner with multiple tool heads and a large reciprocating table, a single housing or open-sided planner. So there is a block diagram of showing the basic components of a double housing planner and block diagram of an open side planner. So there are two different planners in the figure. See here, in the first figure, the indicators are housing, tool heads, tool head, table, bed, cut and return, housing and tool head. And in the next figure, there are feed motion, table, bed, tool heads, column, cross rail, tool head and cut and return also. This is the last slide. Common shaping and planning geometry. So there are some common shaping and planning and geometry. And in this figure, you see here the types of surfaces commonly machined by shaping and planning. So let's see the surfaces, grooves, T-slot, dovetails, flowers and angles. So that's all the surfaces that are used in shaping and planning.